All right, guys, here we go. Example number 3 here, it says find the domain of y equals square root x plus 1. Oh, Mr. C, I got a variable underneath the radical. What do I need to do? Well, I need to say that that variable has to be greater than or equal to 0. So when I write the domain, I'm going to say that the domain is all real numbers, there we go, such that x is greater than or equal to 0. That's the domain. That's what the x's can be. So when I get my table of values and I'm starting to choose my x's, I'm surely not going to choose -2 because x's have to be greater than or equal to 0. So I'm going to choose 0, I'm going to choose 1, 4, 9, just because those are perfect squares, and I'm plugging them into this function. When I plug in 0, I mean at y equals 0, the square root of 0, which is 0 plus 1, okay. The square root of 1 is 1 plus 1 is 2. The square root of 4 is 2 plus 1 is 3. The square root of 9 is 3 plus 1 is 4. Okay. Now, when I sketch this thing, I'm going to get 0, 1. That's interesting. 1, 2. 4, 3. 9, 4. So I have a graph that looks something like this. You know what? That's interesting. Because the graph of the square root of x always looks like this. But since I had this plus 1 up here, okay, it took the whole graph, the entire graph. Whoa, that's not what I wanted. I wanted this little bit. No. Can I get that? No. Okay, not going to be able to. All right. I can take that little thing. It shifted it up 1 because I added 1 to the graph of the square root of x. So it took that thing off of 0, 0 and it bumped it up to 0, 1. All of the y's increased by 1. Okay? So the range for this one, anybody ready to give me the range for this one? Because remember, the range is y values. What's the range equal here, Connor? All real numbers such that y is greater than or equal to 1. Because this graph has moved up 1, James. Do you see that there are no y's less than 1? There are no y's. The first y that begins is at 1. And then it's going to continue to grow, right? Because this graph, when it goes on out to, Iowa, however far it goes, it's going to continue to increase by less and less each time, but still increasing. So there's always going to be a y value as we increase that x. Okay? But there's not one down here. There's not one below 1. All right? So the range is all real numbers such that y is greater than or equal to 1. All right? Great job, guys. Let's see example 4.